So a system of 3 variables is a little bit trickier, but it's done in the same way as a system of 2 variables, just in multiple steps. For instance, let's start with the red and the blue equation. Let's take a close look at them. You can add the 2 equations. Oh, and I'm choosing to add because if you look at the y's, y plus negative y is going to make nothing. Those are going to cancel out. And we always like to eliminate variables. Eliminate uncertainty. Negative z plus negative z, that doesn't make no z. That makes negative 2z because you had $1 in debt, add another $1 in debt, you get $2 in debt. Okay, and so now that we've done that, we have a smaller equation. Let's just keep that off to the side somewhere so we can use it later on. So we combine the bottom two. Let's do the same idea. Let's just now focus on the top two. And let's see how we can combine them. And I'm focusing right now on the y's, because if I eliminate y's from these top two and make a new equation, then I've reduced to another equation that has an x, a z, and a plain old number, just like my bottom one does. And then I have a 2-variable system that I can work with. So basic idea here is that when you have 3 variables, eliminate one by pairing up 2 equations, then eliminate the same variable again when you pair up 2 equations. So here we go. I'm focused on y again, because if I eliminate y here, then I have an x and a z. And then it's just like the black equation I have in the bottom left. So let's multiply that bottom equation by 2. That'll give us a 4 there, that'll give us a 2 there, that'll give us a negative 2z there, and that'll give us a negative 2 at the end. And the reason why I multiplied by 2 is because I want to be able to smush those equations together and cancel out the y's. So now if I use subtraction, that'll cancel it out. I know my writing's hard to read here. 1 minus 4x, you had $1, you took away $4, you're down in the hole $3. The y's would cancel out because 2y minus 2y makes nothing. And now this is z minus a negative 2z. That's adding. Then we have 4 minus a negative 2, that makes 6. So I smushed the equations together, eliminated y, and I came up with a different system. Both these equations have x and z in them. Now you just have a system of 2 equations. A system of 2 variables. That's a lot easier to solve. You've done that before if you've gotten to this section in whatever book you're in. So we reduced it to 2 variables. Now let's try to reduce it to 1 variable. Let's add the 2 equations, and I'm looking at 3x plus negative 3x when I'm adding. Okay, 3x plus negative 3x makes nothing. Negative 2z plus 3z makes 1z. And negative 3 plus 6 gives us positive 3. So there it is. Z is 3. We've got 1 variable. So once you've got 1 variable, take that guy, z is 3, and you can plug it into any equation that you've had before. It'd be easiest to plug in 3 in here for z. Okay, so we got negative 3x plus 3 times 3 equals 6. It's negative 3x plus 9 equals 6. That's an equation you can solve. Subtract 9 from both sides. You get negative 3x equals negative 3, so x is going to be 1 when you solve that equation. So keeping in mind we got z to be 3, x to be 1. Let's go back to the equations we started with. Pick any one of those guys, whichever one you think is easiest. Oops. I'll jot this for a reference. We saw z was 3, x was 1. Plug that into any 3 of those equations, and that'll give you the same y if you've done everything right. So let's just use this bottom one here. 1 subtract y, subtract 3 equals negative 2. What does the y have to be? Well, let's keep that sign when we combine those terms. 1 minus 3 gives us negative 2. Add 2 to both sides. That implies that y is going to be 0. And there's our solution, these 3 numbers. You can check by plugging all 3 numbers into all 3 equations, and it should turn out true.